This is homework 4, part A. So first we need to derive an expression for the optimal flow velocity in a pipe, assuming an annualized cost of CC times D times L plus PC M times F L over D times V squared over 2, where CC and PC are constants for annualized capital and power costs respectively. Here, D and L are the diameters and length of the pipe. F is the friction factor. M is the mass flow rate. And V is the average cross-sectional velocity. I explain how it could be that the optimal flow velocity for water in a pipe has consistently been, explain how it could be that the optimal flow velocity for water in a pipe has consistently been approximately 2 meters per second over 100 years. So first, I'm going to copy the equation down. So try to find the annual cost. That's going to be A C. That's going to equal C times D L plus PC times M times F times L over D that's going to be times V squared over 2. So our first step is to simplify V squared, so we can turn V squared into is equal to 16 times M dot squared over rho squared times pi squared times D to the fourth. So now we can plug this back into this equation, and that'll help us in the end. So I'm just going to rewrite the equation with this plugged in. Okay, and then we have, so this is divided by 2, so instead of 16, we're at 8, because that's 16 divided by 2, so 8 M dot squared all over rho squared times pi squared D to the fourth. Okay, so now our next step is to derive both sides of this. So we're going to get D A C respect to D. So C times L, and that's going to be minus 5 times 8. Write that bigger. 8 times P C times M times 3 F L. So that's the top. Bottom should stay the same. Rho squared times pi squared times D squared. Okay, so now what we want to do is we want to set this equal to 0. And then doing that, we can find the optimal D. So D 40 times PC times F. Then over that we get CC times rho squared times pi squared. Then that's going to be to the 1/6 times m to the 1/2. And so now we're supposed to explain how it could be that the optimal flow velocity for water in a pipe has consistently been approximately 2 meters per second over 100 years. So since these are to the 1/6 power, like these don't really affect it much. So if you change it even a little bit, it's not going to change a lot. So therefore, the same pipe, even if it goes through some changes, it's still going to have relatively the same optimal flow. And yeah.